Hello and welcome everyone. This is Said Manish from Skillable India. In today's session, we are going to cover the topic which is symmetry. Okay, symmetric tolerance, and this is in terms of standard. So we are in terms of standard, we are going to learn this as per the ASME Y14.5 2009 standard. Okay. I have already told you in the previous session also in the concentricity that two tolerances are being deleted as per the ASME Y14.5 2018 standard. So the two tolerances are concentricity and symmetry. Okay. So why they are removed and what are the problems we have faced while using into the engineering drawings, the symmetric tolerance symbol. Okay. So in this discussion, we are in accordance with ASME Y14.5 2009 standard. I am trying to cover you that how we use this the geometric symbol. Okay. So this is the geometric symbol of symmetry, that whenever we are using this symbol, it means this is a symmetric symbol. Okay. This is also a related feature, related to datum. Okay, yes, it is related to datum. So whenever we are using symmetry tolerance symbol, we are with in line with the some datum. Okay, so in this example, with the help of example, we will understand this symmetry. Okay, so with the definition, GD&T symmetry is a three-dimensional tolerance that is used to ensure that two part features on a part are uniform across the datum planes. Okay. In the concentricity, we are talking about the axis, but in this, we are talking about the planes. Okay. We are talking about plane. If we are talking about plane for the this to this, okay. If we are talking about from here to here, there is a different plane. Okay. And for this part, if we are measuring from here, it is having one plane. Okay. Let's say this is having one plane and this point to this point is having one plane. Okay. Just to understand clear concept. Okay. So why it is important that if we are taking 2 point measurement, okay, so we want this plane to be in line with one another, then only it is called symmetry. Okay, so then only it is called symmetric. Okay, so an established true central plane. So this plane should be a central plane is established from the datum. Okay, so if we in with the help of example, I will let you know that how we from the datum, and for the symmetry to be in tolerance, the median distance between every point of the two surfaces features need to be fall near the central plane. Each set of point on a reference feature would have a midpoint. Okay, so whenever we are providing tolerance, so there is a tolerance plane, tolerance zone. Okay, so there is some tolerance zone, some height, maybe it can be 0.1 mm apart. Okay, so whenever we are checking with the different points, so we are getting some median point within this tolerance zone. Okay, so some median points we are getting within the tolerance zone. Okay, and which is in right with between the two. If you take all the midpoints of the entire surface, this must lie within the tolerance zone to be in specification. Symmetry is not a very common geometric tolerance dimensioning and tolerance call out. Since it has very limited functional uses, centering location is done with the position. Okay, so I have already told you that symmetry is not one of the tolerance which we used regularly in the engineering drawings. Because if we want inline with the if we are talking about the center plane and we want an inline, we are definitely going to use the position tolerance. Okay, to make the plane in line with the other datum plane. Okay, so this we will understand with the help of example. Okay, so in this example, we will understand this that whenever we have a part like this, you have center plane. Okay, so this is a center plane. Here I have shown you one center plane throughout the part. But if I am considering this in one feature, this part, feature one, and this part as feature 2. Okay, so both the part is having planes. Okay, different planes. In if they are into the drawing, into the CAD drawing, which is exact drawing. Okay, so in this you can see there is only one center plane. But whenever we are manufacturing this part, whenever we are going and manufacture this part, I have used one term over here. You can see this. I have used datum. Okay. So for this, I have already used datum A. So for this part, this measurement, I have given this center plane. This is a center plane, and this center plane we have used as datum A. So the primary datum this plane we are using as a datum plane. So this plane is called datum plane. Okay, and here we have given the feature geometric tolerance. Okay, which is 0.1 mm apart. So whenever we are talking about this, so it is showing that there are two planes which is 0.1 mm apart, which are 0.1 mm apart. Okay, according to this geometric tolerance value. Okay. Now, in this also, in symmetry also, we can only apply symmetry to a feature. Okay. Symmetry can only be applied, can only be applied to a feature. We cannot apply symmetry to a feature of size. Okay. So in this case, if we cannot apply symmetry to a feature of size, then that means that we cannot use the material condition modifiers, which are maximum material condition and the least material condition. Okay. So if you want to maintain the symmetry between the two feature of size over here, okay, two center planes, that means the center plane of the first and center plane of the second must be on one plane. Okay. In all such cases, we can use symmetry. Okay, so if you give like that, means from the datum plane A, like this is the datum plane. Okay, so this is the datum plane A. You have two parallel planes. Okay, these two parallel planes of which are 0.1 mm apart. And whenever we take 2 point measurement, okay, let's say we are measuring this part from here to here or from here to here. Okay, whenever we are taking 2 point measurement of slots, you get drive median points. Okay, so different median points we are getting over here. At different points, we are getting different median points. So that median points must lie within the two parallel planes, which is 0.1 mm apart. So as I have already mentioned that in concentricity, getting derived median point of different location. Okay, so getting these derived median points of different locations is very difficult. Okay, and we may end up with so many different median points. Okay, so that's why, again, though we apply symmetry to for a feature of size, it is a feature control. Okay, although we are applying to a feature of size, but this symmetry is a feature control only. Okay, so it is a feature control, so we will not be able to apply the maximum material condition and the least material condition modifiers. Okay, so same reason as concentricity, that because this can be applied to a feature only, so for us checking method is also difficult. Okay, because there are different median points at different locations. Okay, so this geometric tolerance symmetry is also deleted from as per ASME Y14.5 2018 standard. Okay, so this symmetry has been removed. Symmetric tolerance symbol has been removed from the ASME by 14.5 standards. Okay, so again, it is being replaced. This symmetric symbol is being replaced with the position symbol. Okay, so I have already told you that in position we can apply to a feature of size, to a feature of size. Okay, whenever we can apply to a feature of size, that means we can use the bonus tolerances. That means we can use material condition modifiers, which is maximum material condition and the least material condition modifier over here. In this condition, you can see that as per datum A, so this plane is datum A, datum plane A, datum plane A. Okay, which is in this case we are using the position, so means we are getting the more tolerance zone because this we have applied to a feature of size. Okay, so in this case we are using the plane as a feature of size, so where we can control the position of the center plane. Okay, in this case, which is 0.1 mm apart. Okay, and the checking methodology is also easier in the position as compared to the symmetry. Okay, so this is one of the very common reason that we use position in accordance with the ASME by 14.5 2018 standard. So the concentricity and the symmetry has already been removed. So this is all about the as per the today's session. Thank you. Thanks a lot.